Okay, let me show you how to implement jump search. So first we need to calculate the size of our blocks. That is super easy. We set block size to math.square-root of array.length. Now here we have a compilation error because this method returns a double, but we have declared an integer. So we need to cast it to an integer. Okay. Next, we need to declare our pointers. So we set start to 0 and next to block size. Now here we need a while loop to advance these pointers and find the potential block where the target item exists in. So while here we need to compare the last item in this block with the target value. How do we get that? Super easy. Array of next minus 1. Because next represents the start of the next block. So next minus 1 is the index of the last item in the current block. Okay. Now, if this is less than the target, that means we need to advance these pointers. So we set start to the next block and we advance next by the block size. Now, in this while loop, we need to watch for those two edge cases I told you about. One is where this start jumps out of the boundary of the array. So if start becomes greater than or equal to array.length, then we're going to break out of this loop. The other edge case is where next becomes too big. In that case, we need to reduce it to the size of the array. So if next becomes greater than array.length, then we need to set it to array.length. That is for the scenario where the last block has fewer numbers, okay? Now there is another way to rewrite this loop. We can add this as a condition at the beginning of the loop. So let's inverse it. We say as long as start is less than array.length and the last item in this block is less than the target, do this. Now, we don't need this if statement anymore. That is better. So this is our while loop. After this while loop, we might potentially have a block to search for the target value. So here we need to do a linear search. That is super easy. We use a for loop. We set I to start. As long as it's less than next, we're going to increment I. Here we check if array of I equals the target value, then we're going to return I as the index. Otherwise, we're going to return -1. Now let's test our implementation. So here in the main class, let's call the jump search method and search for 10. So run the program, we get -1, beautiful. What if we search for 7, the last item in this array? We get 4. What if we search for 0? We get -1. What if we search for an item that should potentially be in this block but doesn't exist? Let's say 2. We don't have that either. Beautiful. What if we have an array with 2 items? We get -1. What if we search for 3? That exists in this array. So see, there's so many edge cases we need to check for. What if we have an array with a single item? So we get -1. What if we search for 1 here? We get 0, beautiful. And finally, what if we have an empty array? We get -1. So this is how we implement jump search.